And let's try exercise 30. Here we're given f double prime, and we're asked to find f of x, and we're told f prime of 1 is 8, and we're told f of 1 is 0. So we are finding the antiderivative of f double prime, which is f prime, and then we're going to find the antiderivative of f prime, which will get us back to f. So f prime of x, again, noticing that this is polynomial with a sum of power functions, I'm going to rewrite my constant multiple, raise x to one higher power, and divide by the higher power. And then again, whose derivative is 5? That would be 5x, or I could think of the 5 as 5x to the 0, and I'm adding 1 to the power, making that x to the first, and dividing by the new power 1, and dividing by 1 is the same as the original, whatever I had. And again, I can start with a plus c, but recognizing when I'm given f prime of 1 equals 8, I can use that to solve for the constant c. So again, recognizing 8 over 4 is 2, f prime of 1 is 2 times 1 to the 4th, plus 5 times 1, plus c, and that's supposed to come out to be 8. So I have c equals 8 minus 7, or 1, right? Because 1 to the 4th is 1, 2 times 1 is 2, 2 plus 5 is 7, and I can subtract that over to the other side. So now I have that f prime of x is 2x to the 4th plus 5x plus 1, and I still need to find a second antiderivative to get back to f. So I'm going to use that rule that I figured out at the beginning. I'm going to carry my constant multiple. I'm going to raise x to one higher power and divide by that new power, plus carry the constant multiple, raise x to one higher power and divide by the higher power, plus, and again I can think of the 1 as 1x to the 0, or what function has its derivative as 1, and that function would be x. And I will temporarily add the plus c, but I'm going to use the other bit of information I was given, that f of 1 is 0, and I can find c. So I'll be finding a particular antiderivative. So in this case, f of 1 is 2 times 1 to the 5th over 5, plus 5 times 1 squared over 2, plus 1 plus c, and that's supposed to equal 0. So I have 2/5 plus 5/2 plus 1 plus c equals 0. Now again, if you're using a calculator, that's fine. You have 0.4 plus 2.5 plus 1, or you can, use a common denominator if you prefer. That's fine as well. I'm just used to working with fractions, so that's what I'm going to go ahead and do. But feel free to try it in your calculator and make sure you can get to the same answer. So I have here 39/10 altogether. So c, if I subtract the 39/10 to the right-hand side, I will get my value of c, which again, if you used a calculator, you probably got negative 3.9, which is fine. So my function f of x, I can write either as 2/5 x to the 5th, or 2x to the 5th over 5, plus 5/2 x squared, or 5x squared over 2, plus x minus either 3.9, or I'm going to go ahead and use 39 over 10 because that fraction form matches my other coefficients. And that's my antiderivative. And again, to check your work, you could find f prime and then f double prime and make sure it matches up to what we started with for f double prime as 8x cubed plus 5. Now there is a table here that I pasted from your textbook, so it goes through some of the basic functions and their antiderivatives. We have the constant multiple rule first and then the sum rule. So a constant multiple times little f would have an antiderivative of that same constant multiple times big F, and that's what we were just using. The sum of the two functions f plus g has as an antiderivative the sum of antiderivatives. We have the power rule that we were using, and just pick out a couple more, right? The antiderivative of cosine x is sine x because, look at the direction of the arrow, the derivative of sine x is cos x. Or, for example, the antiderivative of secant squared x is tan x because, look at the direction of the arrow, the derivative of tan x is secant squared x, etc. So basically, if you take the derivative of the functions in the right-hand side, the derivative of the antiderivatives, you will get back the function that's on the left. Now, I do suggest that you read and work through on your own paper examples 5 and 6 that go over rectilinear motion. There will be a question about that in the homework, and you have this WebAssign 25.